Okay, now it's live. So if we have any questions before they show up, then we can kind of talk about it, and then they can look back if they have any questions. Let me pull
Did you get false for question 3?
up. No, I got true.
Okay. I couldn't tell if that one was true or false. I was having.
It's basically what they're asking is, let's go back up there. You reject the null hypothesis because the null hypothesis is that all the means are the same, and then there's kind of like a variance that they use for that. But if there's at least one mean that's significantly different from the others, then you can reject the hypothesis.
Okay.
At least that's what I got from it. It could be completely wrong. Okay. I got construct a QQ plot for the
For 5.
question 5.
Yeah, I was just trying to find that right now and see if I was right. Yeah.
Yeah, that's what they say.
Where did
And
you
they say that you can.
did
Oh,
you find that in
what?
textbook?
Yeah, it's underneath the requirements of ANOVA 3.2. It says the data are normally distributed in each group. We can check this
Oh,
by creating a QQ plot for each group separately. And if the
okay.
QQ plots do not show distinct curvature, it is reasonable to conclude that the data are normally distributed. And they said that the way that you do that is you just open up the other Excel spreadsheet that we have, the descriptive statistics one, and you can create a QQ plot for each one because I think it's on the second worksheet that they
Which,
have.
the quantitative descriptive statistics one?
Yeah,
Okay.
that's the one that like helps you build histograms and stuff like that and show you like the percentile and everything like that. So on
Okay.
that one, you have the QQ plots, and you can just plug in the data for each one, and then it will show you if it's pretty much the straight line. Then we'll know that it's normally distributed.
Okay.
So I'm on question 6 now. If you're on that one too.
Yeah, I am now.
Oh, gotcha. I know this one. We assume the variance in each group is the same if the following happens. It's if the largest variance is less than or equal to 4
Yeah,
times the smallest variance, then we conclude that they are equal. So that would be question
number 2.
or number 2.
Awesome. Yeah, that's what I
Hey
got.
guys,
Hey, what's up?
how
How's it
much?
going?
Is Celeste not here?
No.
No, he's not here yet.
Okay,
I've invited him though.
okay.
Did you get on here through just an email, like an invite on your Google Chat, or did you get it from my email?
I just went to the Google Hangouts and it shows up as a, you know,
Okay, perfect. I just wanted to see if it worked because I sent you one through your email and I just sent you the invite as itself. So
okay.
Jeremy and I have just been going through some of the questions we've already answered
Mm-hmm.
through 6. Um, so if you want to run through those with really quick, we can catch you up to those.
Okay.
So let me know when you're ready and we can kind of run through those with you.
Okay. All right, here we go. Okay, so in NovenHub, we reject when there is sufficient evidence. That'll be true, right? Number 3.
Yeah.
Yep.
Okay, and what requirements need to be checked when performing hypotheses? These are all positive and equal to variants are equal in each. Normally distributed. So it's the first one and the third one, right? The fourth,
We actually put the second and the third.
second, and the third.
If
Really?
if you go into the textbook,
Mm-hmm.
the two things that it says that there are two requirements that must be checked for the ANOVA test to be valid
Mm-hmm.
is the data are normally distributed in each group and the variances are equal for each group.
Hmm.
The
Okay.
part where it says that, I know what you're thinking because I read the same thing where it says that the answers are never negative.
Mm-hmm.
That's for an
That's for what?
that's just a word. Kind of see if you hang a sticker never negative. So
Okay.
I think it's safe to say that my answers will still be positive, but I don't think that's what they're asking us. Would you back me up on that, Jeremy?
Yeah.
Does that make sense?
Yeah. And then
Hey guys, sorry.
you're good.
You're good. We've just been
I
Jeremy and I went through questions 3 through 6, and now we're just catching up on them really quick.
did you put the first one on the number 5?
We did the second.
We put
Second?
the third one on number 5
Oh yeah, third one. Sorry.
because it's if you read in the textbook, it's that we have to construct a QQ plot.
Okay.
So,
We assume the variance in each group is the same if the following happens. Did you guys put 4 on the number 6?
No.
3?
No.
I don't know.
it's the second one.
The largest variance is less than 4 times the smallest variance. Okay.
If
Okay.
you want to find that in the textbook, it's under 3.2.
Okay.
Kind of explains how we find the variances, and it also explains the rule that we will use for the rest of the time for variances in the test.
Okay.
So, Leslie, do you have any questions about questions 3 through 6?
Let's see.
Wait. What?
Is so for just starting with number 3, that one is is that one true?
Yeah.
Yeah, that one is true.
Okay. And then for number 4, did you guys get
Okay.
do you guys get like the first one and the last one?
Okay.
Is it
No,
the
we got the second and last one.
second and the last one? Okay. And then for number 5, did you guys get the third one?
Yeah.
Yeah.
And then for number 6, did you guys get the second one?
Yeah.
Okay.
So that means that we're all on question now, basically.
Okay.
So I'll read it for us. It says an ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there when there are 4 samples?
I got 6.
I
How
feel
did
like, yeah, how did you get that?
So the way that it's showing is hold on, let me see. So number 1 has the 2 options, which is 2 and pair with 2 and 3, and then 2 has only 1 option, which is 3. So when you add those up, you have 3 options or 3 samples.
Okay.
You kind of do the same thing. That's what I'm guessing. That's
That makes sense.
okay. Good, because I can't explain better than that. So. Oop, too far.
So question 8 talks about the Excel sheet. It says was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 m away from a target that was hung 115 centimeters up from the ground. The column accuracy is a distance
What?
from where the ball impacted the target to the center of the target. So smaller numbers are more accurate. What is the minimum variance for the 6 groups?
I'm just going to put in my variables really quick.
And right now,
Yeah, that's what I'm doing.
wait. Oh. Okay, so what's the question? Minimum smallest variance for a 6 group.
That is, the way you find that is you use the smallest standard deviation
Mm-hmm.
and square it. So you multiply it by itself, and that will give you the smallest variance. Well, hypothetically speaking. Let me see if I can get this real quick.
Wait, you get the smallest. Say that again.
So a variance is the square of a sample standard deviation. So if you were to put in, we have all these different standard deviations. The smallest one is for variable 3, which is C.
Did
Yeah,
you?
But if you see,
ベニー、ダディ勉強してるんだよ。いいけどさ。
because our smallest variance is still like, smallest variance is for, yeah, number C, which is 27.208.
Mm-hmm.
So if you multiply if you were to do it manually, you just go 5.26, 2 and 6 times itself. That will give you that 27.206656 or whatever it is.
Really? I got 27.208.
Yeah, that's what it is in the
Oh.
actual. I'm just saying if you calculate it by hand,
Oh, by hand. Oh,
that's what it's going to be. But that's what I'm pretty sure that's what the answer is.
Is
okay.
it
Yeah, that sounds right.
0.08?
27.208. You can find it on the actual Excel sheet. It'll show you the variance for each group. and you can pretty much tell which one it's going to be by the standard deviation because that's how you find it out.
Well, can't you just look at the variance? It's the same thing.
Yeah, that's what I'm saying. It's just like
Okay.
if you were to do it, if you weren't having that, the way you'd find it.
Okay, yeah.
Oh, okay. That makes sense.
Yeah.
Okay.
So what's the maximum largest variance for the 6 groups? That
I got
would be,
53.135.
yeah. Oh, I got 53.158.
What? Oh, sorry. Yeah, 158. I just mistyped
Okay.
it.
Yeah, 53.158 is what I got.
Good.
53.158.
And then the number 10, the test for equal variance is satisfied for these data.
So that's
Is
when
it-
you have to take the largest one
Mm-hmm.
and see if it's 4 times less than 4 times the smallest one. So the smallest one's 27.208.
Mm-hmm.
Then you like multiply that by 4 times, right?
But it isn't 4 times smaller.
So this will be false.
Wait, hold on.
Or is it?
It's 4 times less than 4 times the smallest variance.
So it's true.
Oh, it's true then.
Yeah, that's true because if you multiply the smallest variance by 4, it's larger than the largest variance that we have. So that would be true.
Okay,
Does that make sense to you guys?
Mhm.
Yeah.
that makes sense.
And then number 11, construct a QQ plot for each of the 6 samples, which each of the samples are approximately normal based on what you see in the QQ plots.
So now we just have to create our QQ plots. This might take a little bit of time.
How are you doing this one?
The way that they showed me in the quickest way to do it is by what the textbook tells us. And the textbook says you can use that quantitative descriptive analysis Excel sheet that we were given, and you just plug it into the QQ plot.
Mm-hmm.
So you just put all the numbers into the QQ plot.
To do them all separately. So you have to do variable 1, you have to put in their number first, check to see if it's normally distributed, and then go to the next variable and do the same thing. Share my screen with you guys really quick so you can see what it kind of looks like.
Okay.
Okay, can you guys see this now?
It's black.
Still black?
There we go. Oh, okay.
Okay, so this is that quantitative descriptive statistics Excel sheet. And this is all the data points from variable 1, or that section A in the soccer shoes. And this is what I got on that. So that tells us that this is not normally distributed. Because if they're normally distributed, they should pretty much be on this line.
Or at least have like a positive correlation, right?
Yeah, it's got to be. There can't really be very much curves, and there's like a lot of curves. Like, it's crazy.
So is this one going to be false then, since A is not right?
Each of the samples are approximately normal based on what you see in the QQ plots. I think we kind of have to see what the other ones look like first to be able to say whether or not that's true. Because if all the other ones are like that, I don't know. I don't know if that makes sense.
Yeah.
See, like creating that. If the points in the plot do not show distinct curvature, it is reasonable to conclude that the data are normally distributed. So I don't know if that the same with you guys, but that looks pretty unequal to me
Yeah.
in this document.
Yeah.
That
Okay.
was false, right?
Yeah, I think it's safe to say false on that one. But yeah, I'd be comfortable saying false. If you guys want to keep working on a section, I'm gonna try another variable and see if it changes.
I got all the way
Okay.
down to D, so, and they're all not equal.
Oh, okay. Then I think it's pretty safe to say the data is not normally distributed.
Yeah.
So that would be false. Thanks for doing that.
No problem.
P-value.
So I'm plugging in all the different variables right now to that other thing
Okay.
for the ANOVA one. Has anyone already plugged it in?
Oh,
No.
Okay.
We still haven't done the number 12, have we? Not? And 13.
yeah, that's what we're doing right now.
Yeah, we're on question 12, right?
Okay.
Yeah,
Did
but I
you?
think that Celeste's just saying that he's putting in the information
Oh, yeah.
into the same.
That'll be faster, right? So, on number 12, we're just removing the SOX data, right?
So if our p-value right now is 0.081, which it is,
So,
variable 6.
so I got 0.309 for that.
I also got that.
Okay.
How did you get that?
We just
What you do is you just go for it, Kazuya.
oh, so you just delete all the variables in SOX data, and that's all you do, and look for the p value on the right corner.
Yeah, the p-value is located in cell M15.
What'd you get for that p-value?
What you should get in the very beginning, if you put in all the data, including the SOX, into those different variable boxes, is 0.081. But then your p-value changes if you remove variable 6, which is the SOX data.
Are you supposed to
It'll
remove
change
it
to
though?
That's what it says. It says perform the ANOVA test and observe that your p-value is 0.081. After that, remove the SOX data and perform the test again. What is
So-
the p-value when we remove the SOX data?
Okay, so you guys got 0.039 or whatever.
0.309.
0.309.
What Excel sheet are you using?
The quantitative inference procedures.
Okay.
When
Yeah, that's what I got.
go into that, it's
309,
the full
yep.
test worksheet.
Okay, I was just lost. Sorry, I got it now.
Yeah,
Point-
I have like 4 Excel sheets pulled up right now, so it's
Yeah,
like
me too.
it's a lot of stuff.
Yeah.
I have that one open. So the p-value is to the right. The test statistic for ANOVA hypothesis is an F statistic. Is the p-value area to the right or the left of the statistic? Let me see.
So I don't know if you guys saw this on the actual worksheet,
Mm-hmm.
but on there they give like a little picture that shows the p-value being to the right of the F statistic.
Where did you find that?
Go on to the lesson 14
Oh.
and on section 3.1. Because an F distribution is a right view distribution, the data that goes to the right of it is smaller. So if you look at your F statistic, which we have on here is 1.261 or 1.216, any data that's smaller than that is going to be to the right of the data. Does that make sense, guys?
メイちゃん、パンダ見るって言ったでしょ？パンダ見てて。
Let me
もうすぐ終わるから。ね？
I got it. That makes sense.
Okay.
So I'm already looking at mine. If everyone understands that.
Yeah, so Yeah, any data that's it's gonna be to the right of it because it's smaller. Okay, and so now we get to use the hot dog data.
Let's examine. We're on 14, right?
Yeah.
Mm-hmm.
Yeah,
Let's examine
question 14. So
construct Q plots of the calories of each of the 3 types of hot dogs and compare the variance to determine if the assumptions to use ANOVA have been met.
So on this one, do we just put in all the data, even if it has the calories and sodium for beef and meat and poultry?
it's saying let's examine the calories first. So what
Okay.
we're just looking at right now is just calories. So first we have to construct the QQ plots of the calories for each of the 3 types of hot dogs, and then compare the variances to determine if the assumptions to the use ANOVA have been met. So I think we have to use both Excel documents.
So I did the QQ plot already. They're
Uh-huh.
still pretty scattered all over the place.
Okay.
On all of them?
Yeah. Or wait, no, that was for sodium. Sorry, I did the wrong side.
Okay.
I'll go ahead and do that real quick.
Okay, and then I'm going to put in the data for the variables to see if we can find the variance. Let's get this really quick. So we're just using calories.
Yeah.
So
Okay, so
it's here. Meat here.
okay.
I'm plugging in those numbers too, Tom. With you.
Then we got poultry. So we only got 3 variables that we have to work with.
So the only ones that we plug in is
Calories.
just the calories, that's all.
Mm-hmm. So
So
our small. Oh, go for it.
so for the QQ plot, the only one that seemed poultry is the very last one, the third one. The first 2 are scattered up.
I wonder what that means.
Can you say that again?
So the first 2 variables, they're
Uh-huh.
pretty scattered over the place, but the last variable, the poultry,
Nope.
is pretty much in the same line.
Okay. Okay, hold on.
Yeah, and I'm pretty sure. I think I know the answer. I'm pretty sure it's answer 3. The assumptions have not been met. It is not safe to assume each group comes from a normally distributed population. But
Yeah,
we can't assume the variances are equal.
Yeah.
Does that make sense to you guys?
Yeah.
Say that again.
It said that I think that the answer is answer 3 because it says that the assumptions have not been met. It is not safe to assume each group comes from the normally distributed population, but we can assume that the variances are equal.
Okay.
So that's for question 14.
What?
Yeah, that was 14.
That was 14, right? That we were just talking about.
Yeah.
Yeah.
Okay.
Mhm.
So the third one. Okay. Oh gosh, please be quiet.
Roommates.
That's not one of my roommates. It's one of the guys that always comes over to my apartment. Okay. You did the ANOVA test, right, Tom?
Yeah, I got the ANOVA test up for the calories.
I did the ANOVA test too. So,
Level of-
what conclusion can we draw? Let's see. We have sufficient evidence to claim all 3 hot dogs have the same mean number of calories. We do not have sufficient evidence to reject claim that all 3 hot dogs have the same number of calories. We have sufficient evidence. All 3 hot dog types have different mean numbers of calories. We have sufficient evidence to claim that at least one of the hot dogs has. So, on the ANOVA test, when you're looking at it, how do we understand the mean by looking at it? What do we look at? Is it the different variables? Right there, it shows the different means. And then it shows their standard deviation and their ends and all those different things.
Yeah.
It seems like, do you see like variable 3 and 4 are very different?
Yeah.
They're like
I'm just going to see if.
because you have probably like 158, 156, 158, and then it goes like to 29, and then it goes to 118. Yeah.
Yeah. You got 156, 158, and then like 118.
Yeah. And the other one is 20. Did you use the third variable or no?
Yeah, I did.
Why is that one so?
That's what I'm asking.
So
I'm just trying to figure out how to answer the question
I know I'm trying to understand what it means
because the means are different.
because the means are really different. Like there's 2 of them that are similar. There's 2 of them that are very non-similar.
Okay.
So I say we eliminate. I say we can eliminate the first and the second, or the first one.
Compare. So we now need to compare the p-value to our level of significance. So our level of significance is 0.05 and our p-value is
0.
the p-value is 3.86.
Oh, you're talking about on our theme?
Yeah. So
Mine shows like this freaking crazy number. Maybe I did it wrong.
So we fail. No, it's greater than it. Smaller than it. We reject. So we fail to reject the null hypothesis if it's larger, correct?
Yeah.
Mhm.
So our p-value is larger than our level of significance.
So
that means we failed to reject the null hypothesis, but the null hypothesis is that all of the that all of the data are equal.
that doesn't make sense. So do we not have sufficient evidence to reject the claim that all 3 hot dogs have the same mean number of calories?
Wait, it does say that our p-value is 0.00. You were right. Sorry, I wasn't looking at that. Why is my p-value showing weird?
Dude, mine is showing super weird too. I
Well,
think
it's
because because it's approaching 0 so much, that's why it's like e to the negative 32. Doesn't that make sense? So if you were to round it 3 decimal places, it would be 0.00. You get me?
Yeah, but I got 3.86. That's just weird.
You got what?
3.86 on my p-value.
Yeah, mine is
But
like
I ended
e to the negative 32, so that means it's really approaching 0.
Your F.
174.737.
Yeah, I think that. Did you put in meat, poultry, and beef on there?
I think I put in, let me see. Why were we not? We're supposed to put those in.
Yeah, you're supposed to put in the calories for that. For all three types and different variables. Because mine's
Put in the
showing that-
calories for all of them. That's the only ones I put in. Were we
That's
supposed to
really
put in
weird.
sodium for
I got-
any of them? Or no?
No, it's just supposed to be for the calories.
Yeah, I just put in the calories. Maybe I accidentally put in sodium for some of those. It doesn't seem like it. So I'm looking at my data right now.
Well, if it's saying that our p-value is 0.00, then we would reject the null hypothesis.
Let me see. I'm just trying to make sure I put in.
Does that make sense to you guys, or am I just like overthinking this?
It makes sense.
So I put my data, the calories in the ANOVA test, and for my p-value, I got 3.862 e negative 0.6.
That's what I got too. But it says on the actual test that it's 0.000.
Well, isn't you said e negative 6, right?
Yeah.
So if you round that to the 3 decimal place, it's 0.00.
Yeah, it is.
Because what e to the negative 6 means, it's over 6 decimal places
Mm-hmm.
from whatever your thing is. Does that make sense?
Yeah, I have a 3 point. It has a 3.000.
So you just move the decimals to the left 6 times.
Oh, okay.
Does that make sense?
Yeah.
That does make sense.
Yeah, so that's why it's 0.000. That's what
Mhm.
they're talking about for the p-value.
Okay. So then that would mean that we have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than the other type.
Okie doke.
Does that make sense? Is that?
Mhm.
Which one did you say?
I think it's number 4 because it's less than our p-value or our
Yeah.
level of significance, so we reject it.
Yeah.
Yeah, I just plugged in the numbers wrong, guys. Sorry.
You're good.
Oh, good.
Okay, now we have to examine the sodium levels.
So I've done the sodium levels for on the QQ plot, and they're all over the place.
Right.
Awesome.
Man, this is so fun.
And our smallest variance is 7.7180.75.
So if it's
And that's
has not been met, so okay.
1, 2, 3, 4, 5. Our largest is still smaller than that. Smaller than 4 times the lowest sample variance. So that means that it would still be equal. So I think it's still answer 3.
3.
Yeah. Does that make sense to everybody else?
Okay. And then on 17, I got 0.179.
0.179.
Yep.
How did you get that?
So you just plug in the data into the thing,
You put
and
all the sodium in.
it shows up on the p-value.
Okay.
So we
Okay.
we do not have sufficient evidence to reject. So it's gonna be number 2
Okay.
on the 18. What do you guys think?
I'm just looking at it right now still.
Okay.
Yeah, I'm still plugging
Numbers are
it
all
in.
messed up.
I'm going really quick.
Well, I'm just gonna submit it right now.
Okay.
So what did we get for? I was just sorry. I was doing the other problem while you guys were talking. What did we get for 16?
The third one.
And then what did you get, Kazuya?
14. I got which one?
The last one.
The
17?
last one is second one. So we missed 2, which is 14, and 11, which is true.
What is 17? What did you get for 17?
17 is 0.179.
So which ones did we miss? What question?
14 and 11. 11 and 14.
Okay.
What was the answer for question 18?
18 is number 2.
Number 2. Okay.
So that means 14 is true. And then
11 true.
11 is true.
11 is true. And then 14, we know it's not that third answer.
What did we get for question 16?
Number
Oh.
16 is
The third.
number 3.
Okay. And then for
So if it's not that one, let's see.
okay, let's examine the calories.
Number
You
5.
think it's? Oh man, let me see.
That 6 is 2. 7 is 6.
Dude, all three of those answers sound super similar. I'm reading them. The last three answers on 15 or 14.
Do something to 10. True. True.
These for the shoes. Calories.
This is for the hot dogs.
Number
Hot dog
14. Yeah.
I'm looking at it right now, just trying to figure out. Oh, that's not-
13. Right.
Q plot for meat. All over the place.
15 is the last. 16 got third.
Meat.
17.
So do we assume that the variances are equal or are they not?
I think it's the last one.
Are you talking about number 14?
Yeah.
That's what I'm just looking at. Why would you say the last one, Jeremy?
I don't know. I got it wrong. I submitted to see if it was the last one, but it's not right.
So then it's probably the second one. Or do you think it's the first one? Huh?
Hold on. Questions. It's not 3, it's not 4. Let me
Yeah.
see if it's number 2. I would think that it's more number 2 than it is number 1.
Yeah, that's what I think too.
Because while all of them are all over the place, they do seem like they match up with each other pretty well. Like I just did all 3 of the QQ pots. So they look like they matched up pretty well. I'm just going to see if that's it, because I don't think that it's the first one. But then again, I could be wrong.
It's math, and it can happen.
Oh, I got it wrong. Ugh.
Seriously?
Is it the first one?
First one?
It's the first one.
I'll laugh if I submit it right now and it's wrong. It's no answer.
None of the 4. They were just tricking us. That's hilarious. Okay, well, I'm going to duplicate this and retake it.
So we're saying
Yeah.
the first one?
Yeah, it's the first one.
Okay.
So did you get 100%, Celeste?
Yeah, if you guys need any, I'll just stay on until you guys finish it.
All right. Well, guys, I gotta go. So,
All
You're
right.
good, man.
all right. See
If
you
you
on
guys gotta
Wednesday.
go, we got 100%. If you just fix those questions.
Yeah, I got 100 too.
Okay.
So. See ya.
Okay, take care.
Yep.
See ya.
See you guys later.
Okay, see ya. I'll just put this on the page.
Okay, thanks, man.
Yep.